How do you combine the rules for roots and powers to solve a problem? You often must use several rules for roots and powers in combination to simplify algebraic expressions. Let's look at two examples to see how this works. First, you want to simplify the expression, the quantity, the cube root of a times the cube root of a squared, squared. You start inside the parentheses. Using Rule 11, you get the cube root of a times a squared. A times a squared is a cubed. And well, the cube root of a cubed is just a. The root and power cancel each other out. So now you're left with the quantity a squared, which just equals a squared. Let's look at a final example. You want to simplify the square root of 4a cubed times b all over 2a to the power of minus 3 halves. In the numerator, you use Rule 11 to write the square root as the square root of 4 times the square root of a cubed. That's then multiplied by b. The square root of 4 equals 2. The square root of a cubed can be written as a to the power of 3 halves using Rule 10. You choose to do this because you already have an exponent with a fraction you can work with in the denominator. Now you can cancel the 2's. There is a negative exponent in the denominator. Using Rule 4 from a previous course, you can move the power from the denominator to the numerator by changing the sign of the exponent. When working with powers, it's helpful to keep those that have the same base together while evaluating the expression. So you move the power up to the numerator. This leaves you with a to the power of 3 halves times a to the power of 3 halves times b. Next, using Rule 1 from a previous video, you can add the exponents together because they have the same base. This gives you 3 halves plus 3 halves, which is 6 halves. 6 over 2 equals 3. So your final answer is a cubed times b. You must often use the rules for roots and powers in combination to simplify algebraic expressions.